All right, so with factoring, we're going to go over 4 approaches before we do the examples on the bottom. So we're going to go over, we've got 3 columns here. The number of terms that we're going to work with, the method, and then sort of the general case, or in some cases you're going to see an example. So 3 columns. All right, so type 1 is basically when you have any number of terms, so it doesn't matter. You always look to do GCF first, greatest common factor, so what they have in common. So now there's no way of generalizing this in a general scenario, so I'm just going to give you an example. So if we have 4a to the third b squared minus 8ab, and we have to factor that, you notice that both of those 2 terms, they have a 4, an a, and a b in common. So we're going to factor that out as a GCF, and then we ask ourselves, okay, well, if I took out a 4ab from 4a to the third b squared, what's left? Well, I have 2 a's and I have a b. If I take out a 4ab from negative 8ab, what's left? And I have a negative 2. The nice thing about factoring is you do have the ability, if you have time, just to FOIL it back out and make sure that it actually does, in fact, give you the original answer that you started with. All right, if you have 2 terms, we've got multiple options. So we have a difference of squares. We have a difference of cubes. And we have a sum of cubes. Sum of cubes. So we have 3 options here. Difference of squares is your a squared minus b squared. So if that's what you get, then you have a minus b, a plus b. The cubes, it might be a little bit new to you. So you either, difference of cubes is a cubed minus b to the third, or b cubed. And how you factor this is you still have 2 parentheses. The only difference is they are not both binomials. One is a binomial, and then one is going to be a trinomial. So with difference of cubes, what you do is for the first parentheses, you basically take the cubed root of each term. So the cubed root of a to the third is a, the cubed root of b to the third is b, and the sign stays the same. So it's a minus b. The second parentheses is based off of the first parentheses. So you take the first term that you wrote, a, and you square it. So a squared. The first sign is the opposite sign of what you wrote in the first parentheses. So this is plus. The middle term are the 2 terms, not the sign, the 2 terms multiplied together. So a times b is ab. The last sign is always positive, and the last term is the second term squared, which is b squared. So when I do the sum of cubes, you might start to see the pattern here a little bit. It's the same process, it's just some things are going to change slightly. So if it's a to the third plus b to the third, again, cubed root of each term, sign stays the same. So a plus b. Second parentheses based off the first parentheses. So the first term is the first term squared. The first sign is the opposite sign than what you see in the first one. Middle term are the 2 terms, not signs, multiplied together. So ab. Last sign is always positive, and the last term is the last term squared, b squared. So those are your 3 options if you have 2 terms. If you have 3 terms, basically that is your trinomial method. Okay, now again, GCF is always to be used first, so always want to check GCF first. So trinomial, there isn't really a way of giving you a general case because there's so many. But if I give you either x squared plus 5x plus 4, and you have to factor that, you get x plus 4, x plus 1. You also could have numbers in front of the x squareds, lots of possibilities. One sec. All right, last and final method is if you have 4 or more terms. 4 or more. So this is your grouping method. So I'm going to give you an example again. So if you have ax plus bx plus ay plus by, that's your problem, and it says factor it. So if it's grouping, you're going to group terms. So I'm going to group the first 2, and I'm going to group the second 2, and I'm going to say, okay, well, what do they have in common? First 2 have an x with an a plus b left over. Second 2 have a positive y with an a plus b left over. You know if you did grouping right if your parentheses are exactly the same. Nothing can be different. And then your answer is made up of 2 items. What you took out, which was x plus y, and what they had in common was a plus b. The order of those parentheses does not matter. Cubes, the order of the parentheses does matter, but for any of the other difference of squares, trinomials, grouping, the order does not matter how you write them in. All right, so let's try some examples here. So first method, A. 3 terms, it's not a difference of square, or 3 terms would put us at a trinomial, but it's definitely not a trinomial situation. We're not doing grouping. So I'm going to look at it and say, okay, well, 12, 3, and 9, they at least have something in common. So this is my GCF. So not only do they have a 3 in common, but they have a 3, an x, and 2 y's. So then I have to say, okay, I take a 3xy squared out. What's left? First term, I have a 4x and I have a y squared. Second term, I have a negative y to the third. And the third term, I have a 3x squared. And then again, check, FOIL it back out. Make sure it actually gives you the original problem. Otherwise, something is definitely wrong. For B, there's 3 terms, so this is a trinomial situation. You say, okay, I need to get 2 terms that multiply to get negative 10 and add to get a positive 3. Well, that's 5 and 2. So x plus 5, x minus 2. I did go over a factoring method. I made fractions with you guys when I did this at the beginning of the year. So there definitely are lots of ways of factoring trinomials. With C, step 1, you look and you say, okay, I have 2 terms, great, but I have things in common, so I got to do GCF first. So I'm going to take out a 2y, which leaves me with y to the 4th minus 16. But then you say, okay, well, 2y is done, but y to the 4th minus 16 is not. That's a difference of squares. So there's 2 methods here. So I'm going to do difference of squares, y squared minus 4, y squared plus 4. And then I still look and I say, okay, 2y is done. Y squared minus 4, that is another difference of squares for y plus 2, y minus 2. And then y squared plus 4 is prime, so there's nothing else that can be done there. With D, you see 4 terms. All of them do not have something in common, so this is your grouping method. So I'm going to group the first 2 and I'm going to group the second 2. The first 2 have a y squared in common with a y minus 2 left. The second 2, again, my goal is to make it y minus 2. So in order to make it y minus 2, I have to take a negative 1 out. So just be careful with that. And then your parentheses are what you took out, y squared minus 1, and what they had in common. But then you say, okay, well, y squared minus 1, though, I'm not done. That's a difference of squares. So don't think there's only one step in the factoring process. Traditionally, a lot of times what you'll find is there's going to be more than one method used. All right, E, we have 2 terms. They're both cubes, so this is a sum of cubes. So we have 2 parentheses that we need. First one is made up of the cubed root of each, so the cubed root of 8x to the third is 2x. The cubed root of y to the 6, basically 6 divided by 3 is 2, so y to the second, and the sign stays the same. First term of the second parentheses is the first term squared. So 2x squared is 4x squared. The sign is the opposite. The middle term is the 2 terms, 2xy squared multiplied together, which stays 2xy squared. Last sign is always positive, and the last term is y squared squared, which is y to the 4th. And for F, I'm going to go over my fraction method. So this is, again, trinomial situation. We are looking for 2 numbers that multiply to get negative 72 and that they add to get a 1. So that is 9 and negative 8. So because this is a 6, you can't do what we just did right here. You can't just write x plus 9, x minus 8. It's not going to work. So we set up 2 fractions, and you could have done this with B as well. 6 is your numerator, 9 and negative 8 are your denominators, and you simplify. 6 over 9 is 2/3. 6 and negative 8 gets you 3 over negative 4. Always keep that negative in the bottom. The top goes with the variable, and then you have your parentheses. Here's 1, 2x plus 3, and 3x minus